This is the 11th video in my series on using Google Sheets to do inferential statistics, mostly by running simulations to find p-values, and the third using categorical data. We're looking at whether or not people who agree that nobody deserves a free handout from the government are more or less likely to believe that small working class towns in America's heartland deserve a handout from the government. So far we can see we have 270 people who agree that there should be no handouts from the government, except apparently to small working class towns, 87 people who are consistent and believe that there should be no handouts even to those groups. We have 286 people who are also consistent. They believe that they don't believe nobody deserves a free handout. In other words, they believe people do deserve handouts, and that includes small working class towns. And another 32 people who are really jerks because they disagree. They think that people do deserve a free handout unless they're in small working class towns. So those 32 people really are jerks. Let's see if there's any difference at all between these two groups. Let's find the proportion of people who agree with no handouts that want to help small towns and a proportion of people who disagree that want to help small towns. So this will be the proportion of agree. This will be the proportion of disagree. This is the people who agree divided by people who agree and want to help small towns divided by the total of people who agree. This is box E5 divided by box G5 equals E5 divided by G5. 75% of people who agree that the government should not be giving out handouts, 75% of them want us to help small towns, as opposed to the disagrees. This would be box E6 divided by box G6. Equals E6 divided by G6, 89%. So there is a difference there. How much of a difference? Let's subtract those two. Equals E10 minus E11. So 14% more people want to help small towns among those who disagree that the government disagree that nobody deserves a free handout. So if you think that people do deserve a free handout, you're 14% more likely to want to give a handout to towns, which makes sense. If you think the government should help people, you want to help small towns, that all makes sense. It's a little surprising the difference isn't more than 14%. But now let's ask the question, is that 14% statistically significant? The next thing I'm going to do is start randomly assigning these yeses and nos to the agrees or disagrees. That's going to mess up all the work I've done here. So before anything else, I'm going to duplicate this sheet. Now, because I've set these all up where they're just counting yeses and nos within ranges, if I randomize all the yeses and nos, one more thing, I want to retype this difference. I don't really care about the negative, 0.14306, 3068, retyping that number here, except I don't really need the equals either, so that as I randomize and this number changes, I will be able to remember what it was. I'm going to randomly assign the yeses and nos to the agrees or disagrees. All four of these numbers should change, but if I've set this up correctly, these totals should not. The total of these two should still be the same. The total of these two should still be the same. And let's see what happens. Randomize range down here. And indeed, the yeses, the nos changed. The totals stayed the same. By randomly assigning the yes and the no's, only 4% was the difference between the agree and the disagree, much lower than the 14% we observed. So this is a failure. We cannot generate a 14% difference relying on just random chance. One trial does not a data set make. Let's try again. 1% difference, fail. 1% difference, fail. 2% difference, not even getting close to that 14% difference. So we can conclude that that 14% difference, as small as it is probably statistically significant, meaning it's probably not due to random fluctuations in the data. It probably is true that people who want the government to give free handouts also want those free handouts to go to small